Hello, Advanced Geometry. It's Mr. Donaldson. Today, we're going to talk about triangles. This is section 1.5 in your text, so you're welcome to follow along there as well to get a little bit more clarification on anything. Let's get into it. All right, guys, so before we start talking about triangles, though, this is just like a quick reminder regarding how you're supposed to use the markings that are in diagrams so that you know what the heck's going on, okay? So first of all, let's talk about what you are allowed to assume. So the first thing says is you are allowed to assume that lines are straight. Here's what I mean by that. If you have some diagram like this, for instance, and maybe there's like a point there, you can assume that this is a straight line or an entire 180-degree angle, okay? You can assume that. Because, if you just look at it, maybe you're like, well, maybe it's only 179.9 degrees or something. No, any line that appears to be straight and anything that's drawn, you can assume most certainly it is. All right? You can assume that lines intersect at one point. And so what that is trying to say is that, if I have some intersecting lines here, you know that exactly one point is their point of intersection. Or, for instance, maybe we have a diagram like, like this, and there's no point shown there, well, you know that that point exists, and you can talk about it, you can label it, and so forth and so on. And then last thing you can assume is that points in a diagram are coplanar unless planes are drawn. So unless there's shaded planes, unless there are dotted lines, you can assume that all drawings are coplanar. So you can assume every single one of these drawings are taking place on one plane. They're all coplanar. All right? Things you may not assume. You cannot assume lines are parallel unless they are explicitly marked parallel, such as with the arrows like you see here. So I know in this diagram that line AB is parallel to line CD, but I don't know if they're parallel to the other ones or not. They could be, but they don't have to be. Same with perpendicular. We only know or can be certain that lines are perpendicular if they have the little box there. So in this diagram, I know that line JK is perpendicular to line JM, but I cannot assume the other lines are perpendicular. I cannot assume JM is perpendicular to MQ. You cannot make those assumptions. And you cannot assume things are congruent. So angles or segments or polygons, you cannot assume they are congruent unless they are marked congruent with the appropriate markings, just like you see in this diagram. I know that segment UT is congruent to segment VT because they are both marked with three little congruency symbols. So here's just an example, and we can just run through these quickly. Which of the lines are perpendicular, which are parallel, which angles are congruent, and so forth and so on, okay? Or which triangles, are congruent. So let's start here. So in this diagram, the only thing I can deduce based on markings is that line AB is parallel, line AB, don't forget that symbol means parallel, to line CD. I do not know anything about those other lines because the other lines do not have the little parallel marks. In this diagram, the only thing I can assume, just as I mentioned a second ago, was that line JK is perpendicular. So upside down T, remember, means perpendicular to line JM. I can not assume that KQ, line KQ, is perpendicular to MQ. It looks like it, but unless that little box is there, I cannot make that assumption. Next thing it says is which pair of triangles are congruent. All right, well, I know for sure that by definition, triangles are congruent if all of their corresponding parts are congruent. So let's take a look. Obviously, this one has angles and sides. This one has angles and sides. So it's probably these two, and let's just check. All right, so angle U here has three little hash marks, and angle Z has three little hash marks. And then from U to S, so I'm just going to make my assumption. Let's see, triangle U, and we'll just see if this holds. Triangle U, and then, let's see, that had three little hash marks, and then Z had three little hash marks over here. And then from angle U with three hashes to angle S with one hash, it goes through a side with two ticks. And that's the same here. From Z to X, you go through a side with two ticks to an angle with one. So I'm going to say S here, that's going to correspond with X here. And then finally from S to T, I go through one tick mark to a two tick marked angle, And from X to Y, I go through one tick mark to a 2 tick marked angle. So I know that triangle UST is congruent to triangle ZXY by being very careful and paying close attention to those congruency marks. All right. Over in this triangle, over here, I know that segment VT is congruent to segment UT because you can tell that they both have 3 little tick marks. So the whole idea here is just don't assume things. If the markings are there, you use that. But if they're not there, you cannot assume things are congruent, parallel, perpendicular, etc. All right, let's get into triangles. Here we go. A right triangle, you guys. A definition of a right triangle. Here are a couple right triangles. Here are some non-right triangles. Of course, this one's not a right triangle. It's not even a triangle. But you'll notice that in the right triangles, they have one 90-degree or right angle. So a triangle with a right angle. And I know we haven't learned this yet, and you may know this already, but a triangle, the angles add up to 180 degrees. You can only have one right angle. So maybe instead of saying with a right angle, I'll say with one right angle. It's not possible to have more than one right angle in a triangle. An acute triangle. And in an acute triangle, you notice these are all acute. These are not, and here's what makes this one not. This one has a right angle. This one has a big fat 122-degree angle. Notice that in all the acute triangles, every single angle is less than 90, so they're all acute. So a triangle with 3 acute angles. Every single angle in that triangle is acute. Wonderful. And then last but not least, and again, you guys, right now what we're doing is we're classifying these triangles by their angles, okay? So we're essentially describing this triangle just based on the angles it has. So you can have a right triangle, you can have an acute triangle, and then finally you can have, if this will scroll down, an obtuse triangle. And you notice, here are my obtuse triangles, here are non-obtuse triangles. Well, this is obviously not a triangle. None of these angles are obtuse, they're all acute. This would be an acute triangle. This one has one right angle, this would be a right triangle. So an obtuse triangle is a triangle with one, just one, obtuse angle. And for the same reason that we were discussing with that right triangle up above, you can't have more than one obtuse angle in a triangle. Perfecto. Alright guys, sorry about that. My software kind of glitched out on me. So now what we're going to do is we're going to now classify a triangle by its sides. So we just talked about classifying by angles, whether it's a right triangle, acute triangle, or an obtuse triangle. But you can also classify or characterize a triangle by its side lengths. So let's talk about how you classify a triangle by its sides. All right, so focusing on the side lengths and not the angle measures. So here the first one is a scalene triangle. And you'll notice that in this non-scalene triangle, all the sides are the same. And in this non-scalene triangle, you got 2 sides are the same. And in this obviously is not even a triangle. But you'll notice in a scalene triangle, all the sides are different. And that's exactly the definition. So a scalene triangle is a triangle with no congruent sides. None of the sides are congruent. They're all different lengths. An equilateral triangle, you guys should know this. We already discussed what an equilateral polygon was. It was all the sides are the same, and that's exactly the case for an equilateral triangle. Kind of disregard the angles here for this one. We're really only focusing on the sides, but if all 3 sides are the same, they're all 8, they're all congruent, it's equilateral. These non-equilateral triangles, they don't have all congruent sides. So an equilateral triangle is a triangle with all sides congruent. And then the last one here is an isosceles triangle. And you'll notice in my examples of isosceles triangles, like, okay, we got a pair of sides congruent. This one has all 3 sides congruent. This one has 2 sides congruent. This one has 2 sides congruent. Over here, none of the sides are the same length. Over here, none of the sides are the same length. This one's not even a triangle. So you'll notice just by looking at the examples of isosceles triangles, it's not just with one pair or with two sides congruent, it's at least two sides are congruent, because they're saying that this one's isosceles as well. So a triangle with at least two congruent sides. And what that means, you guys, is that an equilateral triangle is just like a special kind of isosceles triangle. And I know my triangle symbols are pretty bad on this tablet, but bear with me. Great. Okay, so parts of an isosceles triangle. So first there's the base. The base is the non-congruent side. The legs are the congruent sides. The base angles are the angles formed by the base and legs. And the vertex angle is the angle formed by the legs. So the legs of this triangle are the congruent sides. You can tell by what's marked here that segment BC is congruent to segment AC. So they will be the legs. Segment BC and segment AC would be the legs. The base angles are the angles formed by the legs and the base. The legs and the base. So that'd be angle A and angle B. Those would be my base angles. Sorry about my handwriting. I know it's terrible. All right, the base. The base is the non-congruent side. So that would be segment AB. And then finally, the vertex angle. The vertex angle is the angle formed by the legs. So that would be angle C. Perfecto. And then the last thing, guys, is just a little drawing exercise. If you want to pause right here and try to draw these on your own, if you're watching this video, that'd be great. In class, we're going to do this together. So pause and then just check your answers and see if you got what I got. So here we go. Right isosceles triangle ABC with right angle A. So I'm just going to do some rough sketches. I know my drawings are terrible. Hopefully you guys are better than me. So I'm drawing an isosceles triangle. It's got to have a right angle. Let's see. We got legs A, B, and AC and right angle A. So let's start like this. I got my right angle A. And we'll put a B here and a C here. And I want the legs, or the congruent sides, to be A, B, and AC. And right angle A. I think I've satisfied that. I got a right isosceles triangle with right angle A and legs A, B, and AC. This one I want an equilateral triangle, so I'll go ahead and draw that. And I'm going to cheat a little bit to make this one nice and pretty. You guys don't have that option, I imagine, but check it out. Boom, I got an equilateral triangle. It's XYZ. So X, Y, Z. And I want angle X to be bisected by ray XM. So I'm going to bisect angle X. And I'm going to call that ray XM. And I'm going to mark that it's being bisected with my little angle congruency marks. And then the last one here is obtuse scalene triangle, CAT. So I want it to be obtuse. I want all the side lengths to be different. That's pretty good, I guess. Nothing looks the same. We can't assume they're the same if I don't mark them congruent, so that's good enough. Let's see, I want obtuse angle ACT, so for sure that big fat one's got to be ACT. And I also want segment CM to bisect segment AT. Now remember, to bisect a segment means to intersect it at its midpoint. So I'm going to draw a midpoint on segment AT, the one that's being bisected, and then I will draw that segment from C to there and call that point M. So I've got an obtuse scalene triangle, CAT. I didn't mark any of the sides congruent, so I can assume it's scalene. All right. And let's see, I got obtuse angle ACT, that was the big fat one. And then I drew segment CM such that it went through the midpoint of segment AT, and I marked that appropriately. There you have it. You got to really know your vocabulary well to be successful at understanding these drawings and really understanding what the book's asking you to do. So good luck with your assignment.